The broadcast is now starting. All attendees are in listen-only mode.
So, welcome everyone to our VRA webinar on the impact assessment for automated door system, which will present and discuss results from the CityMobil2 project. Before starting the webinar, I would like to provide just few practical information. First of all the participants will stay muted during the presentation. You have a control panel to post question, and you can use to write question during your presentation this panel. And if you have question on specific slide, please refer to the number. During this webinar, after this short introduction, we will have a presentation on the framework for impact assessment with discussion on international cooperation by Satu Inama of VTT. Then some results from the long-term impact for SC by Carlos Sessa, and then we will have some presentation of expectation by Mike McDonald. After the presentation, the project coordinator of CityMobil, Adriano Alessandrini, will join us, and we can have a short question and answer session. Before giving the floor to Satu, I would just spend a few words on the support action VRA. This is a support action funded by the European Union to support a collaboration network of experts and stakeholders for the deployment of automated vehicle and infrastructures. The support action was mainly involved in the supporting the network of the iMobility Forum. It provides also support to the Trilateral Europe, US, Japan working group on road and vehicle automation. And then it works for on a specific topic such as regulatory issue or digital infrastructure, and also impact assessment. I would like to remind that the project developed a Wiki, that is a knowledge database of several European founded projects and other initiatives on the topic of automated vehicles. You have here in this presentation all the contact for our website and our Wiki. Before closing, I would just remind that there is currently another support action that has been recently launched to support the networking and automation. This is the CARTRE project, whose main activity will be to support the joint stakeholder network and also to coordinate activity for the data exchange and common evaluation framework. So some of the let's say results that we will discuss here will be also input for working activities in the future. This is a short overview of the part of this project, CARTRE, that involves both industry, research institutes, and also other companies in the framework of transport. Thank you very much for your attention. Now I will give the floor to my colleague Satu Inama from VTT to present her activity on the impact assessment framework. Satu, the floor is yours.
Thank you. Okay, now I think my slides should be visible to you. So yes. I will tell you about this international cooperation on building a framework for impact assessment on automation in road transportation. And why should we assess the impacts of automated driving? Well, first of all, we should not implement new concepts just because they are technically feasible, especially if the public money is involved. We should know the consequences of the concept. And automated driving will potentially have large impact on our daily lives. It will have some direct impacts, but also indirect ones, some intended impacts and unintended. Some of the impacts will take place in the short term and others in the long term. The impacts will be different for different levels of automation, and they will be different when the vehicle or the traffic flow will be only of automated vehicles and in the mixed traffic phase. And we should know whether these impacts are in line with our societal goals, and we should know whether automated driving is accepted by the public. Well, we have this Trilateral Impact Assessment Subgroup for Automation in Road Transportation. It was formed in March 2015, so almost 2 years ago. Our objective was set to harmonize the high-level evaluation framework for assessing the impact of automation in road transportation. And we have chairs from the 3 continents. I'm the chair for Europe. Scott Smith from US DOT is the chair for US, and Nobuyuki Ushida from JARI is the chair for Japan. And currently we have 37 participants, and in Europe we cover Finland, Sweden, UK, the Netherlands, France, Greece, Belgium, Italy and Germany. So rather large working group and very active one. The motivation why should we harmonize the impact assessment framework is that, as I said, the potential impacts of automation are far-reaching and complex, and there are high expectations how do these connected and automated vehicles affect our societal goals. Another thing is that field tests, they are expensive, so not everyone can test everything. And as I said, some of the impacts will take a rather long time to form, and they can be rather indirect. So with the small vehicle fleets that we can have in FOTs, and with the small or short time frame, we might not be able to test everything. So with international harmonization, if we are able to design tests and studies so that we can maximize the insight obtained, that's of course good thing. And it would be good to do some meta-analysis and perform the tests in a way that is enabled as well. We should be able to arrange complementary evaluations across the world and make better use of each other's findings, and not to just repeat things, but to really know what has been already tested and to complement to that. And of course, exchange of best practices in impact assessment is always beneficial. The actual framework that we are now currently developing, we said that for the first priority we would define which impact areas we recommend to cover, define what we mean by each impact area. We just noted after working for a while that common vocabulary is very important. We might utilize the same terms but maybe mean different things, so that is good to enhance the understanding internationally. Of course, we'll try to define the KPIs, the key performance indicators, with which we recommend the impacts to be expressed, and we'd like to provide some recommendations for the baseline and anticipated impact mechanisms. If we have the time and resources later, we'd like to recommend a minimum set of data to be shared for the impact assessment studies, define the time frame that the impact takes time to form, and to facilitate the meta-analysis and comparability of results, so defining the agreed target years and scenarios. And of course, we are not building this framework from scratch, but we have the automated vehicle benefits framework from the US, and we have the FESTA framework from Europe. We are looking at direct and indirect impacts. With the direct impacts, we have here the graph on the slide. The ones that are above are mostly direct impacts. They are related to costs, infrastructure, safety, vehicle operations, energy and emissions, and personal mobility, so ability to multitask and accessibility of citizens. Of course, those have also some indirect dimensions, but mostly direct one. And then there are some indirect areas like asset management, network efficiency, travel behavior, public health, land use, and socioeconomy, which then have implications also for the direct ones. We have created a lot of graphs on trying to describe and show the various ways how automated driving will impact our lives potentially. And this is one example where you can see what will what will be the consequences of that, the fact that if the automated vehicle can deliver itself. The green lines with the plus signs, it does not mean that it will be necessarily good impact, it means an increase. And the red ones means just decrease. It may be good or bad, but it's not taking that into account. So increase by green and decrease by red. And here, if we follow the paths, for example, that if the automated vehicle can deliver itself, we will have some zero occupant trips, which will increase the vehicle miles traveled or kilometers traveled. On the other hand, if the vehicle can deliver itself, it will increase the convenience of car sharing, and we will have households replacing owned with shared vehicles, which will then have less demand for parking, etc. So all this kind of frameworks, how to systematically go through the impacts and areas, will be shown in the framework. The document, which is currently under work, is that it's meant for those who are, first of all, doing the impact assessment. I hope that it will be helpful for them, but also for those who are designing the FOTs, and for policymakers who might be willing somebody to do an FOT for them and may have some research questions in mind. The content of the framework document will include introduction, recommendations for impact areas, impact mechanisms, recommendations for experimental procedure and data sharing, and some conclusions. And this is the first phase document that we are currently building. The next steps are that we will finalize this first full framework draft by the Trilateral Automation in Road Transportation Working Group meeting, which will take place in early January in TRB. And after it has been accepted by the working group, we will then collect some feedback and present it to the professionals in this field, and then collect some feedback and maybe do some updates if seen necessary. But this is more or less the current status of the work, and I hope that I will have something more to show you early next year. So follow the CARTRE, the follow-up project of VRA, and then other activities where we might be presenting the work done by this subgroup. So thank you.
Thank you very much, Satu, for your presentation, very interesting. I would like to welcome in the webinar also the coordinator of CityMobil2, Adriano Alessandrini. Welcome, Adriano.
Thank you very much. I'm very glad to be here.
Adriano will support us in this webinar, especially in the let's say in the last part of question and answer. But I would like also to give to you now the floor for before discussing, I mean, the activity of CityMobil, to give really a very short introduction of what has been the activity in CityMobil, and a bit an overview on the project. So we will show some slides from our side. You should be able, okay, to see them now.
Good. Thank you very much, Davide, to organize this webinar and to give us the opportunity, now that the project is finished, to present some of the results. As probably most of the people attending the seminar knows, CityMobil2 has been one of the major European initiatives in the 7th framework program on fully automated road transport systems. So we basically brought on the urban street in several cities fully automated minibuses to carry passengers. The project had 9.5 million funding, 45 partners, and it was completed at the end of August. If we can go to the next slide. We see here all the different demonstration and showcasing activities. Basically, the 3 large-scale demonstrations had the full fleet, so 6 vehicles each, for a minimum time of 6 months. We carried a lot of passengers there. Small-scale demos had less numerous fleet, but had nevertheless a significant time to demonstrate, and carried a significant number of passengers, different environments, and then we also had a very small showcasing, so basically just 1 or 2 vehicles brought for a few days up to 1 week at conferences or in other occasions. What we were actually aiming with the project is to demonstrate not only that the full automation in cities, on urban roads, in mixed environment is feasible today, which we successfully demonstrated, but also to try and collect the user reaction and understand better how these things can really become, not in 10 years' time, but tomorrow, a real part of the urban transport systems. And this is what Mike and on the future scenarios, Carlo will be presented later today. So if we can go to the next, and I think the last slide, this is just to show how many vehicles kilometers and how many passengers we have carried in the different demonstrations. As you can see, we made more than 60,000 passengers on urban street, which up to my knowledge is an unprecedented record for fully automated systems on urban roads. So with this, I think I can just leave the floor to Professor Mike McDonald to basically introduce which are the outcomes of all these evaluations that we carried out, mostly in the large-scale demonstrations, but not only, to assess the impacts and the potential impact of this system. Davide, I don't know how to pass the floor
yes,
to Mike, so I leave you to do it.
Okay, first we will have a short presentation from Carlo Sessa before, and then the presentation of Mike. So
sorry, so my mistake. So Carlo will speak first about the long-term scenarios, so to try and understand how automation will really impact our society in the long term, which is one of the tasks that we had within CityMobil2. This is of course not based on the demonstration results, but it is based mostly on exchanging opinion with experts and to try and see different scenarios on how this will apply. Sorry about this misunderstanding, Davide. Go ahead.
Great, thanks Adriano. Carlo, the floor is yours.
Okay, you can see the presentation on the screen, and actually, as introduced by Adriano and by the former presentation, we had to deal with an extreme complexity of the potential impact of a more extensive diffusion of automation, automated driving. And the CityMobil project did demonstration at the site level, and Mike will present that later, some examples, but also organized with by means of a Delphi survey and a workshop that was held in La Rochelle with around 100 participants, international experts, and a qualitative scenario, qualitative appraisal of impact scenarios exercise. To frame this exercise, we used two basic concepts. The first concept is represented in these slides, is a schematic representation of the urban forms, because basically we needed to think to how the scenario of road automation could work in different kind of urban context. In this scheme there is basically an horizontal axis that is about the density, by one side with aloneness in less dense context, do it together more dense context, and the vertical one is the speed of transport, fast or slow. So in the urban sprawl we have typically the large metropolis where the problem are the suburbs with a sprawl of locations around a center. A city network is a city where we have a polycentricity, so there is enough critical mass for connecting the different centers also with some form of public transport, fast public transport. There is another form is the small compact city, the typical city that is relatively far from other cities and is organized with the short distance trips within the cities. And finally, rural areas, tourist areas, which are much more sparse. So we asked all the participants to think at these 4 urban forms and how automation could work, with kind of impacts in these different urban forms. In addition, the second concept was that we framed the future in terms of 2 possible different caricatural scenarios. Caricatural because they are somehow extreme. The reality will be much more mixed, of course, but the idea was to imagine a scenario in which autonomous vehicles develop as private self-driving cars without changing the basic behavior of car ownership. So the basic idea is that in that case, the car will become more efficient, more comfortable, and that will have an unintended consequence in terms of increasing the comfort of distance travel and the number of trips and facilitate further urban sprawl. The other scenario is a shift in behavior also, a more radical shift toward sharing the cars and not owning the cars. And this is a shift that is of course connected also to other drivers, demographic drivers, lifestyle change drivers, especially the behavior of the so-called millennial in the cities. So there are a lot of factors that are making the car sharing something that is no more only a niche development, but could be, in these scenarios, was presented as becoming a dominant way of living in the future. And so this scenario is based on the organization of fleets of shared cybercars into an automated urban environment. And then the basic point is that thanks to 3 characteristics, the fact that in this way driving accessible to all, also to people that doesn't hold a car or is able to drive a car, first point. The second point is the fact that automation will, in this scenario, provide the supply of transport on demand and everywhere, not only in high dense areas or corridors, but also an organization for providing that in more rural or peri-urban areas. And finally, the basic point of automation that actually can provide, after the initial investment cost for doing the services and the infrastructure, but then thanks to the fact that you don't have job-related costs, basically the service can be provided 24 hours, 7 days continuously. So basically the idea that this will create the potentiality for a polycentric urban development with people living in cities and also with some kind of nomadism possibility to live part in the center of the city or to shift to other places around, thanks to the fact that the service will be much more diffused and available. So basically on these basic ideas presented at the start of the Delphi survey, we applied an impact scenarios methodology, a methodology for letting people think what are the likely change in the key variables: daily trips per capita, average journey distance, occupancy rate, car ownership, and modal share in the 4 forms that I presented before. Then we had an impact pathway formulas to be that used this variable in input as they are estimated. So the mechanism was educated guesses from the Delphi survey participants. As they are estimated, they are used as an input in the impact pathway formulas to provide a qualitative appraisal of what are the consequences of these changes in transport variables on some impacts for economy, for society, for environment, for transport that are shown there. Now I will present other slides with the conclusion about what were these impacts in these two scenarios. And scenario one is the private car use development, automated vehicles. Scenario two is the shared fleets of cybercars, automated urban environment. So basically in the first scenario, there will be an increase of vehicle kilometers that could not be compensated by better vehicle performances, use of platoons and lower cruising speeds that are characteristics of a more regular automated driving mode. So basically it's a negative consequence, this one. Of course, these are examples of negative or positive consequence that in the previous presentation we have seen in the very nice scheme of the complex system. We tried through the judgment of these experts to foresight what could be this kind of positive or negative inputs. In scenario two, there could be a problem of waste from relocation of empty vehicles that could be balanced by the shift to a pervasive car ride sharing, which becomes a substitute basically in this scenario of public transport systems. And land use, the impact on land use. Basically, automation will produce potential saving on parking space, but in the first scenario will be relatively low, this saving, because it doesn't change the behavior of the user so much. There could be high demand on land use outside city areas because it's much more comfortable and easy to reach these areas, and the higher infrastructure and city running costs. In the second scenario, we have basically a greater impact on parking space, very low need for car parks everywhere. So we could have a recovering of land use within the cities for other uses than parking the cars. You know, I think you know well the issue that the car today is for almost 94% of the time not used, parked somewhere, and only for 6% of the time used for traveling. And easier to manage the interface with the public transport and car sharing fleets, what I said before. In this scenario of car sharing fleets that are dominant, we have actually a reorganization of the public transport system. We could have no more the traditional public transport with the bus stops, but much more flexibility in the system. Urban requalification somehow is connected to land use, of course. Most of the urban, scenario one, most of the urban infrastructure spending still goes to maintain an urban road network, and there is no much impact on urban requalification because there is not so much room for that. On the contrary, in scenario two, the idea is that thanks to this reorganization with less car traveling in the cities for more vehicle kilometers, for more total travel time, basically we have more space for creating more livable cities using a parking facility for other purposes. And the opportunity to rethink and renovate the urban environment for pedestrians and the automated vehicles and deliveries. Basically, one idea in this scenario would be to have a kind of automated transport zones, which are an evolution of the concept of traffic calming zones. A zone where pedestrian and low-speed automated vehicles can be mixed together. Safety, the impact on safety in basically, the basic idea for the participant was that society in any case will not allow a system on the road that is less safe than today. So basically, in this scenario was considered neutral, the impact of automation, because technology will not allow it to go on the road if it is not safe enough. In scenario two, there is a greater reduction in accidents expected thanks to a reduction in drinking, driving, and fatigue. Let's take the example of a person living in a village near near a city that has to return to the house in late evening and have an automatic service at the park and ride location with a cyber car leaving him back to home, to the village. In that case, you can travel, of course, more safely. Not to say about the drinking behavior of some people, no, that would be totally avoided in this case. Okay, accessibility was obviously another important dimension. Of course, this is an area where both the scenario are expected to produce favorable impacts. Accessibility for disabled and the blind people, because the automated car, when the problems with the perception of safety, of security, of automation is overcome, actually the driving a car will become much more easier also for elderly people. And the other point about accessibility is that thanks to the automation, it's possible for a household that is living in a far destination to keep only one car that makes the work of one automated car that can do the work of two cars that typically are used by households in these more countryside or rural environments, thanks to the possibility of empty vehicle return to keep other members of the families. In scenario 2, also this idea of extensive fleets of cars used in park and ride location will improve significantly the accessibility also in rural areas. And could be used, this flexibility, also for increasing the supply of services in touristic areas that have the problem of managing the peak of demand, which is very different between the low season and the high season. Finally, this is the last slides with miscellaneous impacts that we were not able to distinguish in scenario 1, scenario 2, according to the results of the survey and the workshop with the experts, but are of course aspects that are to be considered. Affordability is a key issue. How much will the new vehicle, automated vehicle, cost? What business model for new collective fleets? Because if we want to have shared fleets, we need to have business models that are viable in economic terms, and basically they could be subsidized as public transport is today, partly. Health, what impact will automated demand response vehicles have on our health? There could be good impact in terms of security, of course, less accidents, but we will stop to walk or ride a bike because comfort is so high. This depends a lot from uncertainty about the behavior of people. Personal security interface will make a huge difference to acceptability and perception of personal security, because an automated vehicle, and especially at night and evening, could be a problem in terms of not feel you alone in the situation. Finally, perception of travel time will change, because of course the comfort in travel is such, and even the attention that you don't need to give to driving is so different. You can imagine driving in an autonomous vehicle on a highway in a platoon. You can do your work exactly as you are on a train, and the same could be for the truck, the automation of truck, that people could even sleep partly of the journey. So this is the end of the presentation of the results of this exercise. Thank you for listening.
Thank you very much, Carlo, for this beautiful short presentation. There is one question which is addressed directly to you which maybe you can answer before going to Mike, which is in scenario 2, they are asking whether you are envisioning shared cars in terms of property, but not in terms of trip, or both.
Basically, it could be both, because the point is to have a fleet of car sharing that are available to, thanks to the automation, are available to reach one user, to leave one user and to take another. So it was basically thought in terms of car sharing. But of course, when you start to think at the scenario in which owning a car is no more a status symbol or the average condition of people in the city, also ride sharing could be added into the picture. But then we should think to other factors coming in terms of behavior. For example, to which extent people would like to share rides with others or not. We have already.
Thank you very much. Thank you very much, Carlo. And now it's time to move to Professor Mike McDonald's presentation, who has acted as the evaluation leader for the CityMobil2 project. Mike, the floor is yours.
Okay. As a background, when the project started, there were no automated vehicles of a minibus type which were available. So one of the major successes of the project has been the development of the vehicles, and it started off as a process where the initial vehicles were rather crude, and then at the end of it they were very sophisticated and very practical. The evaluations took place through that period of change, and so that will have had or have some small effect on some of the outcomes within there. The other is that these results are dealing with small minibus type of vehicles, and they all had a groom on board, somebody who had an ultimate role as being responsible for safety, and that also will have had some effect on the feedback. Next, please. Slide, please. Thank you. There were a series of surveys. You saw from the earlier slide from Adriano where the cities involved were. The early results from Oristano were relatively small, but they were very useful in 2014 in identifying some of the issues we needed to look at. The major cities from which there were significant results are given here, and you can get an indication of the sorts of sample sizes of the surveys. And the evaluation covered user experience. There were stated preference surveys which were tied to revealed preference surveys afterwards. There were surveys of pedestrians and cyclists. There were wider public surveys of the city's attitudes of people in the city in terms of their attitudes, and there were the stakeholder surveys, which were the public authorities and the private authorities that were involved, the public transport operators, manufacturers, and so on. Next, please. There's a lot of different results, and I'm just putting up one or two and then some general implications. First one is that from the surveys, one of the questions that were asked was the public attitudes towards owning or sharing automated cars. And there was a general feeling, a positive feeling towards automation within there, and that came across also as it moved into the automated vehicles that were trialed within CityMobil. Next, please. Next slide. Essentially, people were offered the choice as to whether it be an automated vehicle or a conventional minibus type of operation for these services. In general, the automated vehicles were perceived as being more attractive within there, and those with arts experience, the experience of the automated vehicles, there was a higher acceptance of people within there. So they liked the automated vehicles. There were various effects of gender and age, and they were not consistent across the three cities, but there were some quite subtle understandings that were developed from that. The main outcome of that is people liked to use the automated vehicles. Next, please. People were asked how they would see them operating, because within the trials they were in fairly limited applications. Some of them were in pedestrian cycling areas, some of it was crossing roads with conventional traffic, some of it was on roads with conventional traffic, with some element of segregation within there. And people were asked what they thought the systems should be like in the long term, or what sort of role they would be. And the key outcome of that is, for most of the cities, was to provide feeder services. So that you would see these as part of an integrated public transport system covering the last mile. Maybe more than that, but that is how people generally perceived them. Tricolor was the exception, and the main feeling for the role there was to provide services in tourist areas, and that was because that operation was in the city centre of Tricolor, which was connecting the major activity areas within there. So people perceived them as being a feeder service generally within the system, or operating within a single area. Next, please. Various deployment scenarios were taken forward, and La Rochelle was one of the key cities, and they have the automated systems now as part of their sustainable urban mobility planning. And this is one of the indicative routes that they would be considering, and that provides a link from the railway station to the port area, the main tourist area, around the city centre, and tying in to the main public transport access point of buses that come into the city within there. They would see this as a major attraction. It would be free to users within there. When we looked at the overall costs, the cost of these vehicles are relatively high at the moment. They would come down in the longer term, but even at the higher cost, the operation, if they were fully automated without anybody on board, you have about a 25% saving on your total economic costs, total financial costs, against a conventional minibus. Next, please. So there's two final slides just as an overview. The first one is just to reinforce that there was a very positive attitudes that came towards the automated vehicles. Everybody liked them. They were really rather nice. On the basis of the findings, we realized more precisely what needs to be done, and there needs to be new large-scale field trials. And one of those is to operate the vehicles in a wider range of real traffic situations, and that requires legal barriers to be overcome, and there has been some activity on that. The second is route selection to get a much better integration. So the routes were selected that gave quite a range of activities, but one of them is to try and get a greater integration so that you have a more general change in modal split towards the use of public transport. Practical operations need to be confirmed over a much wider range of conditions. There needs to be higher average operation speeds, and that doesn't mean that the speeds have to be higher in those areas where there is most conflict with pedestrians or cyclists. It just means that there needs to be sections where speeds can be higher so that you end up with a total journey time which is relatively short. there needs to be the complete operational security and emergency management systems, and they were first developed in the project for use in Lausanne, and they just need to be taken forward a little, but are being very effective. There needs to be comprehensive surveys to improve understanding of the socioeconomic impact and the longer-term behavioral issues and behavioral interactions. All the vehicles in these trials, in these demonstrations, had grooms in them, and so other users were often aware that the vehicles could be stopped. They were not relying totally on automation decision-making. The development application of targeted awareness tools, so that you have apps in there so that people are aware, and you have them as part of an integrated system and service. And then lastly is to look at the financial economic assessment, including fair paying options, how that operates, how that goes forward. Next slide, please. What the demonstrations did show is that the automated vehicle control was accurate and consistent. It works. The next point is that human interventions were observed during ART's vehicle running. If you have a groom on board, and if you tell them that it's their role to be ultimately responsible for safety within there, then there will be a tendency to intervene a little more than perhaps they need, than they need to, that the automated system will cope. And that is an area where we need to have the trials with fully automated systems without anybody on board. And for that, there needs to be some improvement in the vehicle technologies, software and hardware, but that towards the end of the project we're improving very, very substantially, and I think we're probably at the stage now where we need to have much more full-scale trial of vehicles fully automated, where we can really start to understand what the applications would be. Okay, that's all I really wanted to say. The evaluation was undertaken by a series of teams, including CTL and Isanova, as well as ourselves, and so Carlo or Adriano may want to add something to this.
Thank you very much, Mike. Before going to the questions of the audience, I have a question for you and maybe for Carlo as well, which is after all this experience you had, not just in CityMobil2, but culminated in CityMobil2 with fully automated vehicles, what do you expect actually to be the first system that needs to be implemented, that will be implemented? Where do you see these to start and then to grow? Mike?
Of the cities that tried these as demonstrators, La Rochelle and Lausanne want to take these forward. So there has been a lot of public support, there is a lot of institutional support, and they want to take those forward. And I think the next thing is to try and get some very much more substantial trials where we're moving to full automation in services which are providing a real modal choice integrated into other public transport. So it's giving the last mile.
Thank you. Carlo, if you're still online, what are your views? What do you think is the ultimate, or I mean the first and then the ultimate step to bring this technology to market?
I think that there is the possibility to see a development of the automation beyond the last mile application, because I agree with Mike that basically the first steps of the market will be to develop some last mile application. But for this it's important to understand that all this cannot happen in a while. It will be gradually can be extended. And I think it's important to create a bridge between the strategies of the industries that are progressively automating the vehicles. And basically, I see that trend for a trend that will achieve level 4, but the problem is how to step up to level 5, because there are implications about the behavior of the driver of a single car that enter into the picture. And the other side, the possibility for the cities to develop what in the project we have called automated urban environments, which are not only last mile solution, but zones where some car fleet shared services are provided, limited surface zone in a certain sense. I think that could be the next step of the market development after the more immediate steps.
Neither of you is actually seeing highly automated corridors as the next step. For example, to have these last mile vehicles that actually can enter a high-speed corridor. Mike?
Well, yes, Trilateral, as you know, have proposed that. So you have park and ride sites, a high-speed corridor. You have the collection from the park and ride sites, high-speed corridor, and then central area distribution. And that is clearly a possibility within there, yes.
Yes, I can confirm that was one of the considerations done in the polycentric city network scenario, the possibility on the highway connecting these cities that already have a very high density of transport to have congestion, making traffic make more fluid by organizing the infrastructure to host platoons of vehicles that should shift to the automated modality when they are there. This is a scenario in which basically dual vehicles are vehicles that you can use for driving on manually, and then to shift to automated driving mode when you are on high infrastructure with high density flows.
We have a couple of questions I selected about costs. The first is what is the estimated cost for these automated vehicles, and the second is maintenance cost, whether it's been estimated or not. If I can try to give a rough answer to the two questions about the cost of the vehicles, we are talking about 250,000 euros per vehicle, but the target price, so once they will be mainstream, is more in the cost of 100,000. Of course, the more these vehicles are sold, the more the technology becomes mainstream, the less the vehicles will cost. There is already a few companies which are putting on the market smaller vehicles, fully automated, 4 places, for 75,000. So this is something which is, of course, very much evolving and evolving very quickly. I mean, I believe that more than the vehicle cost at present, we need single vehicle cost, but how much you will need to invest overall to start the control room, to have the infrastructure and everything. Overall, we have to say that in our project we spent about 1.5 million, a little bit more than 1.5 million on each fleet, and we spent for 6 months demonstration 400,000 in each city. So it means that basically and everything cost about a third of the vehicle costs, which is not negligible, but not even very much. In terms of maintenance cost, we had a tremendous cost for maintenance, but basically because, as Mike has said at the beginning, we were working with prototypes. So even when the vehicles became more production line vehicles, we still had the first vehicles out of the production lines, we still had the prototypes of the production line. So to give you examples, we had mechanical failures, we had problems with the screw that was holding the automated braking, which was not accessible because we had a small problem of the design. So basically to intervene on that screw, we had to remove an axle, or we had a problem on another fleet of the suspensions getting down because it was not correctly dimensioned. Now, these are nothing to do with the maintenance of the system, because this is the problem that you normally have with prototypes. So we don't have real estimations. However, we can expect maintenance to be, as always, in the range between 6 and 10% of the vehicle cost per year. Then we have another question which I'd like to address to our two guest speakers, which is which are the main technical barriers to achieve the improvements that you have identified during the project. Mike?
Right. I don't believe that there is a substantial technical barrier to the latest vehicles that are out there in terms of the sensors, in terms of everything from door mechanisms to entry to the physical design, all the aspects of the physical design of the vehicles. So I think it is probably likely to be some behavioral issues, that if these vehicles are running in an automated way, and they may be running at night, it is the feeling of security that people will have, so that it is the communication between knowing what is happening in the vehicle and that communication with the central control system and the security associated with that. But in terms of the vehicles themselves, for the sorts of speeds that they are likely to operate at, and that is not motorway speeds, it is urban speeds, the quality of detection is now really very good. So we still need to understand the behavioral response to other road users, particularly cyclists, for example, who may come up behind a vehicle and swerve in front of it, but the technology is all there to get that understanding, to model it and to anticipate it much better than the average driver would do.
Thank you very much. And we also received another question which I believe can be well responded by Carlo, which is about projection on when do you expect these systems to get to market. Actually, this is not a good question because they are on the market today, but I mean probably to become mainstream on the market. This was the main of the aim of the question. What do you expect, Carlo, when they will become mainstream in the market?
Actually, we have even projection that can become mainstream in after 2013, 2035, or something similar, because we have projection for automated vehicles to take over the market in the next decades, and not in the next 50 years. But in terms of foresight, of course, this is, I guess, a little difficult to be done. In our foresight exercise, we have imagined a kind of shift to a majority of cars automated in the city in 20 years from now. That's the idea. However, because foresight is not predicting exactly the event, it's not possible. The main point is this is related also to the question before of the technological barrier. I think that the barrier are not so much technological. I'm not expert enough for answering to that, but basically behavioral. And from the point of view of the behavior, one should think which strategy to follow for the automation of transport. And our idea was that we should have a strategy that is based on using automation when and where it makes sense, and not trying to fully substitute the human beings in the driving task, as the fully autonomous vehicle goal strategies following as a goal. What I mean is that one point is to try to let automation take over the really routine task of traveling, not the more pleasant tasks of traveling. And that would mean to have a strategy in which the vehicles really are used for things that now are bothering people, as for example, leaving the car to go to a parking, not necessarily to substitute the people when they like to drive in a countryside road, which is nice to drive over. So it's really a matter of combining the strategies of the industries that are developing the technology with the strategy of the planning and territorial and cities authorities that are influencing the quality of future urban life and transport.
Carlo, Mike, thank you very much for having been such wonderful partners in the project with really meaningful results, and for being such good speakers today and to keep timing so well. Unfortunately, even if questions are still flowing in, we don't have time to answer because we have to close. So I just give back the word to Davide Brizzolara to the closing information. Thank you all for spending your time to know once more about the CityMobil2 project.
Yes, Adriano, thanks to you for moderating this webinar. I would like from our side too to thank all the speakers that participated to this very interesting webinar, and I would like to remind that the presentation and also the recording of the webinar will be available on the website of VRA, so you can download the presentation and eventually look the video if you want. So thank you very much to the audience, and have a nice weekend. Bye.